Okay, so welcome back, and today we're going to do another example, but this time we're going to deal with Maclaurin polynomials. So in this example, we want to use a Maclaurin polynomial. We want to find the fifth Maclaurin polynomial to estimate sine x. Okay, and then we also want to find the bound for it as well. So we want to, so there's two parts. Okay. So we want to find, we want to use the fifth Maclaurin polynomial of sine x to approximate sine of pi over 18. Okay, so we want to approximate sine of pi over 18 using the fifth Maclaurin polynomial and bound the error. So we want to bound the error using that. Okay, so now, let's write out the fifth Maclaurin polynomial. So we know from previous videos that sine x, the Maclaurin polynomial that represents sine x, is given by this, which is this partial sum, okay, for n greater than or equal to 0. And so if we write the fifth polynomial is going to be this. So P of 5 of x equals what? It's going to be x minus x cubed over 3 factorial. And since we're doing the fifth, well, we're going to go out to the next one, which is going to be x to the fifth over 5 factorial. Okay, and so that is the fifth Maclaurin polynomial. And so we're going to use this. So basically, sine of pi over 18 is going to be approximately equal to p of p sub 5 of pi over 18. Which is going to equal what? Well, now we're just going to put in pi over 15, or excuse me, I'm sorry, pi over 18 for each one of these. Okay? And so what do we get? We get, let me write this out. We get pi over 18 minus pi over 18 cubed over 3 factorial plus pi over 18 to the 5th power over 5 factorial. Okay, and so if we put this in our calculator, then what do we get? We get this is equal to approximately, what do we get here? So it's approximately equal to 0.173648. Okay? Now, so that's the approximation of sine of pi over 18 using the Maclaurin partial series, or the fifth Maclaurin polynomial. Okay, now, to estimate the error, we're going to use the fact that the sixth Maclaurin polynomial is the same as the fifth Maclaurin polynomial. Okay, and calculate a bound on R6. Okay, so now by the uniqueness of the Taylor series, again, remember the Maclaurin series is just a very specific type of Taylor series. We know that R6 of pi over 18, right? So R6 of pi over 18 is equal to what? It's going to equal f to the 7th, I'm sorry, it's n plus 1. So seventh derivative of c over 7 factorial times, well, in this case, it's going to be pi over 18 to the 7th power. Now, again, this is based on some c in the interval from 0 to pi over 18, right? Just like before. So now, we're going to use the fact that because this is a sine, right? Because this is sine, we're going to use the fact that the derivative is going to be less than or equal to 1, the absolute value. So again, remember, so this is the fact that the absolute value, the 7th derivative of f of x, the absolute value of that has to be less than or equal to 1. Okay, for all x. And so that means we can find the magnitude of the error is at most. Right? So since this is true, then guess what? The error, so let me, you know what, I'm going to erase this because I don't need this anymore. So we know that based on this, we know R6, the absolute value thereof, of pi over 18, has to be less than or equal to, well, what? Since this is bounded by 1, right, based on this, so that means this has to be less than or equal to 1 over 7 factorial times pi over 18 to the 7th power, which is given by approximately equal to what? Well, if we stick that in our calculator, we get 9.8 times 10 to the negative 10th power. 9.8 times 10 to the negative 10th power. Okay. Now, so now we found our estimate. So here's our approximation of sine of pi over 18. Here's the maximum error, right? This is the remainder, right? So the remainder is no bigger than this. Okay, so now we've got that. Now, the second part of the question is we want to find the values of x such that the fifth Maclaurin polynomial will approximate sine x to within 0.0001. Okay, so now the second part is now what we want to do is we want to use the fifth Maclaurin polynomial, and we want to know, hey, what x value will make sure that our estimate is within 0.0001, okay, of the true answer. Okay, so now to find the value of x, well, guess what? We already know this has to be true. But now, guess what? Well, this means that R of 6, oops, right? So that means R of 6 of x has to be less than or equal to what? Well, it's going to be 1 over 7 factorial times the absolute value of x to the 7th power. We have to have the absolute value of x because, again, x could be negative, right? So we want, since we have the absolute values of x and we don't know what x is, then we have to have the absolute values of x here. That's obvious, right? Here we didn't need the absolute value because it's a positive number, okay? Here we're trying to locate x, so we've got to make sure we have those absolute value signs in there. Okay, so now this is what we're trying to solve. Okay, so that's where we're starting. Okay, now this we want to be less than or within, so we want less than or equal to 0.0001. Okay? So now all we have to do is solve for this inequality here. Okay? So if we solve for that inequality, well, we're going to multiply both sides by 7 factorial. Okay, so that's going to give us the absolute value of x to the 7th power is less than or equal to 0.0001 times 7 factorial. Okay? And so what we're going to do is then take the 7th root of that. Okay? So we can take the 7th root of both sides, right? And so we get the absolute value of x has to be less than or equal to the 7th root of 0.0001 times 7 factorial, which is going to be approximately equal to 0.0907. Is that right? Or is it 709? Let me check. Where is it? 907. So that's correct. Okay, so that is the answer. So the absolute value of x has to be 0.907. So, well, actually, this should be less than, because it's within. So this should be less than. Less than. Okay. Okay, that's it. Have a great day.